Nearly 3,000 Google API keys scattered across millions of websites can now silently access private AI data and drain billing accounts. Keys that Google spent over a decade telling developers were safe to embed publicly. For more than 10 years, Google maintained a clear message to developers. API keys for services like Google Maps weren't secrets. They were designed as harmless billing identifiers for public services. Embed them in your JavaScript, check them into GitHub repositories, share them freely. Google's own documentation encouraged this practice. Then came the AI boom. Google launched Gemini API services containing sensitive data, uploaded files, and expensive large language model usage. The problem? Google used the exact same API key format for these new sensitive services. Every Google API key starts with AIZA, followed by 39 characters. Whether it's accessing public map tiles or private AI conversations, the format remains identical. This architectural decision created what researchers call retroactive privilege expansion. When a developer enables Gemini API on their Google Cloud project, every existing API key in that project automatically gains Gemini access. No warnings, no notifications, no explicit permission required. Keys that were harmless yesterday become sensitive credentials today. The scope of exposure is staggering. Attackers can access uploaded files, cache conversation data, and charge large language model usage to victim accounts. New API keys default to unrestricted access across all project APIs, amplifying the risk. Researchers scanning millions of websites found vulnerable keys from major organizations, including Google's own internal systems. The irony is profound. Google's keys were exposed using Google's own insecure practices. This represents a fundamental shift in Google's security model. The company that pioneered secure by default principles created a system where old public credentials become private keys without user consent. It contradicts over a decade of guidance about API key safety. The technical root cause lies in Google's credential architecture. Using a single format for fundamentally different security purposes creates confusion and risk. Other cloud providers typically use distinct credential types for public versus private access. Developers now face an impossible choice. Trust that Google won't silently expand API permissions, or treat all Google keys as secrets, requiring rotation and secure storage. The latter approach breaks existing applications and contradicts years of established practice. Google's response has been notably muted. No mass notification to affected developers. No automatic key rotation for vulnerable credentials. No changes to the default unrestricted access model for new keys. The broader implications extend beyond Google. As AI services proliferate, other cloud providers face similar architectural decisions. Will they learn from Google's mistakes or repeat them? For developers, the lesson is clear. API key security models can change retroactively. What's considered safe today might become a vulnerability tomorrow as new services launch using existing credential formats. This incident highlights the tension between backward compatibility and security evolution. Google prioritized seamless AI service adoption over explicit security boundaries, creating a massive retroactive vulnerability. The 3,000 vulnerable keys represent just the discoverable surface. Countless more likely exist in private repositories, internal systems, and legacy applications where developers followed Google's original guidance. Moving forward, expect increased scrutiny of cloud provider credential architectures. The AI boom is forcing fundamental questions about how authentication and authorization should work across diverse service portfolios. Google's API key vulnerability reveals how quickly security assumptions can shift in the AI era. Yesterday's harmless billing identifiers become today's backdoors to private data. The challenge for all cloud providers is maintaining security boundaries as their service portfolios rapidly expand into new domains with different risk profiles.